Also, good afternoon, dear ladies and gentlemen, esteemed colleagues and friends. It is a great honor and pleasure for me to welcome you to the kickoff event of our online discussion series, Groundcheck. And please allow me to start my really short introduction to the topic with a small example and two pictures. You know, when the architect Friedrich Hinkel photographed, for example, Meroe's pyramids in Sudan in the 1980s, he saw intact and decorated stone surfaces. 35 years after Hinkel's photographs, you can see that the pyramids have lost most of their decoration and sharp edges. The sand of the desert has eroded the surface, something like a sandblasting machine. While in old photographs, only a little drifting sand can be seen today, the pyramids are swallowed by enormous sand dunes. You see that the UNESCO World Heritage Site is in serious danger. And this month, the site is also threatened by a Nile flood, which is unusually high this year. It is a new danger for Meroe as an archaeological site. But what is the reason for the two extremes, the spreading of the desert and the flooding? What influence does human intervention on the ground have and had, and which role plays the global climate change? Intensive agricultural use, together with several dry periods, has changed the landscape in this part of Sudan since the 1960s. Overgrazing promoted desertification, leading to a loss of vegetation which held back the sand. So on the one hand, the desertification is a local event caused by human actions. But on the other hand, global warming also promotes aridization and desertification. The question for our time as well as the past is, how are human intervention and the global and local changes in environmental conditions connected? This question is currently intensively discussed in connection with the introduction of the term Anthropocene for a new man-made age. Man shapes nature, intervenes in it, and changes it in a way that has never been seen before in history of the Earth. Man has become the influencing factor on geological, biological, and atmospheric processes on Earth. But when did the Anthropocene begin? With the industrialization in the 19th century, in the post-war period of the 20th century, or when people began to intervene more deeply in their environment through agriculture and animal husbandry? That would mean in the Neolithic period, for example, round about the 6th millennium BC. With the term Groundcheck, our online discussions focus on the local triggers and ramifications of environmental and climate change. We will analyze during the following meetings local terrestrial environmental data and their dependence on human intervention and global change. And we will analyze these complex relationships in great temporal depth. And this is the only way to understand the causes and effects that lead to change. Scientists and scholars of different disciplines and from all over the world will discuss the topic during our next 6 meetings. The spectrum ranges from natural sciences to humanities. Our opinion is that research into the past provides key data for understanding global climate change and its consequences for cultural heritage. It lays a foundation for developing sustainable solutions for the future. And this is also the goal we set for our discussions, our Groundcheck. Originally, we planned to meet physically in Berlin in March this year for 3 days. Now we are meeting in this Zoom way virtually and have restructured the program to 6 evening sessions, as you can see on the picture. Today, we begin with the topic from model to impact, the reconstruction of past climate changes and their consequences. On September 30th, we will look into the past with the impact of climate change on early cultures. On October the 7th, we will discuss the topic water management and desertification, one of the most challenging issues for many regions of the world. On October 14th and 21st, our focus lies on the impact of climate change on cultural heritage. As the conference is now spread over many evenings, we will end with a final discussion and summary on October 29th to bring together the various contributions. But now I do not want to hold any more of your time and attention with my introduction. I want to thank all participants for joining us from all over the world in order to conduct a ground check from their scientific perspectives. I would like to thank the Federal Foreign Office and the German Parliament for supporting the ground check research program launched this year. And I would like to express my special thanks to my colleagues from the German Archaeological Institute and the Archaeological Heritage Network for the organization. And lastly, I would like to thank the renowned science journalist Volker Wildermuth for serving as the moderator for all 6 sessions of our conference, and who will now introduce today's topics and speakers, panelists to you. And I hand over to you, Volker. Thank you very much for your attention.
So thanks again for the introduction, Professor Fless. So past societies had to cope with climate change, and we are all descendants of people who were quite successful in this task. So there must be lessons to be learned from the perspectives of archaeology. And I can tell you in my talks with the speakers, I've already learned a great deal. Climate change, we all experience it or describe it as a global phenomenon, but the challenges it proposes for people are always local. And therefore, the ground check discussions will focus on how changing climate plays out in very different settings and societies. Our first discussion is titled From Model to Impact, Reconstructions of Past Climate Changes and Their Consequences. And we will look at the data. How can we know about the fluctuation of local climate, the responses of plants, and how people cope with the waxing and waning of their resources? We will start off with 4 short presentations. Then there will be a discussion among the speakers on the panel. And finally, all of you can ask your questions, either using the chat function within Zoom or on Facebook or Twitter. But now let me introduce our speaker for the day. There's Professor Hans-Rudolf Bork. He's a geographer based at the University of Kiel and a member of the Cluster of Excellence Roots, Social, Environmental, and Cultural Connectivities in Past Societies. He looks for signs of dramatic climate events in the landscape. Paleontologist Professor Paweł Tarasov is a specialist for pollen and tree ring dating from the working group Paleobotany, Paleoclimatology, Human Environment Interactions at the Freie University of Berlin. Paleobotanist Michèle Dinies is his colleague at the same institute of the Freie Universität Berlin, and she looks at pollen as well, but in quite different settings. Finally, archaeologist Professor Detlef Gronenborn. He's a deputy head of the Competence Center Prehistory at the Römisch-Germanisches Zentralmuseum in Mainz. He looks for developmental trajectories driven not by climate, but by factors within societies. To start off, we will go not too far back in history. There are documents from the year 1342 of heavy rains, devastating floods. However, are these exaggeration or are these accurate reports? Professor Hans-Rudolf Bork, how deep had you to dig to find the answers to these questions?
So thank you very much, Volker, for this introduction. And just let me start with a very short PowerPoint presentation. I want to concentrate on just one event. So climate is the average change of weather over decades. Let me pick up just one element of this climate, one extreme event which occurred in the 14th century. So several years ago, we carried out archaeological research south of the Harz Mountains in the landscape Untereichsfeld, east of Göttingen. And in a huge excavation, about 13 meters deep, we found the filling of a gully. You will realize it here in this little sketch, which was about 10 meters deep, and from side to side, this is a cross section parallel to the slope, we found filled gully by filled gully. And at the bottom of the filling, there were some pottery fragments which we could date into late medieval times. And then we continued to investigate more and more profiles in the region, and more pottery fragments and other material was found to date the event, the one event that cut these deep gullies. And finally, we came to the period 1330 to 1350. And now in the next step, we had a look at the written sources that were available. And they clearly show there is only one extraordinary intensive event in late medieval times. And that started at the 19th of July in the year 1342 in Franconia, so in southeastern Germany. And then this extreme rainfall went to the northwestern Germany and brought a really unusual intensity of rainfall, of runoff, and thus of erosion. Just to illustrate how extreme the flood was, when you compare it with a major flood of the River Oder in 1997, or with the Elbe floods in 2002 and 2015, in 1342, the water which passed the major rivers in central Germany was 50 to 100 times more compared with the more recent events. So something extraordinary happened, and about 13 billion tons of soils were eroded, reducing the soil fertility dramatically. So many fields couldn't be used any longer. And then a few years later, the bubonic plague came in. And just to be in a correct order, I first have to mention that we have had a high population density at high medieval times, very intensive land use, often an unbalanced diet, and then a first extreme weather period, 1309 to 1321, the Dante anomaly. Then the rainfall I just mentioned shortly, with strong erosion, the devastation of arable land, and then a bubonic plague from 1342 to 51. So the population density was dramatically reduced. We can prove in our profiles that there was a wide abandonment of agricultural land use, and new woodlands started to grow in the late 14th and the 15th century. So overall, the area which was covered with woodland in Germany tripled, and people started to keep namely pigs and cattle and other animals in the new woodlands, and that enabled a change in diet. So all these aspects of this extreme period in the 14th century illustrate the very complex interaction between human activity, intensive land use, and extreme weather events. Thank you.
This was one devastating event, but climate change often develops not in a single event, but over a longer time period. And now we look at such developments and we go back deeper in time to the mid-Holocene. Climate events of this time can be reconstructed using biological proxies, tree rings, ancient pollen. Paleontologist Professor Tarasov will focus on two regions in China. Do pollen help you not only to follow the climate, but the human reactions as well?
Yeah, thank you very much for introduction, and good afternoon, dear friends and colleagues. So let me start to introduce our research, which has been done in cooperation with a big group of colleagues and students all over the world. And so just to indicate that this is not my result of the single researcher, but a result of the big group where with people whom I had the pleasure to work with. Well, the discussion of man and climate is not new, but if we are thinking about these two phenomenon, we can always say that man and climate went together through their history, simply because there doesn't matter where you are living, where in which time and which place, you are always dealing with a certain weather and certain climate. There are some theories even saying that climate change and its effect on the ecosystem played a very important, a key role in the human evolution. And on this picture, you see the certain proxies, so the environmental proxies from the African continent and surrounding seas. And you see the very strong trend toward the dryness over the last 4 million years. And this change in the environments and climate also somehow is parallel to the development in the human family and the final evolution of Homo sapiens, anatomically modern man. Well, what we can learn from the past? We know that the meteor station around the world show a clear trend towards global warming. But this data only covers the last 100 to 150 years at best. On the other hand, various indicators, for example, plant pollen records, which I'm working with, can archive climate characteristics of the entire pre-industrial period of human history. I told that I'm working with pollen of plants, and this is, of course, a very powerful proxy. I would like briefly introduce you and say what is the secret of the pollen power. Pollen grains are very abundant. This knows everyone who has a car in Germany, especially the early summer, or who has a pollen allergy. The pollen grains are representative, so they are everywhere where plants are growing. They are well spread. That's why they are very common in the lake and mire sediments. So this is very important for paleontologists. Pollen grains are very resistant because of the very resistant cover. They can survive in the sediments for millions of years, not only for thousands. And what is also important, pollen grains produced by different plant taxa are recognizable. And here on this example, you see just 3 grains representing grasses, pine trees, and birch trees. And it's already for non-specialists understandable that they are very recognizable, very special in their shape. So all these features of pollen allow very reliable reconstructions of vegetation and land use, but also modeling of the vegetation communities and the land use, and last not least, quantitative climate reconstruction. I must tell that the work between sampling of the sediment core in the lake or peat bog between the sampling and getting the final result is very long and very hard. So it's including a lot of time and a lot of work. You see here, well, on this slide, it's shown very simple, but in fact, in order to extract pollen from the sediment and then count 300 to 500 grains per sample, it takes a lot of work. So we need to be patient and we need to be grateful to the people who are doing this. Talking about the reconstructing the past. Well, the concept, the model of the reconstructing the past from pollen is very simple. Climate is determining factor for the vegetation in every given region. And the vegetation, of course, produce this particular pollen grains. So if we counted the pollen grain in the sample and realized what is the composition of the taxa, we can reconstruct the vegetation and then reconstruct the climate. By the way, 100 years ago, Vladimir Köppen, famous climate researcher in Germany, said that native vegetation is the best expression of climate. Now we are coming to 2 examples, short examples they are coming from Eastern Asia. You see the territory of East Asia, China, and the site Taixijuan is just located on the range of the dry belt of the Northern Hemisphere, indicated here in yellow color. The site now, it's actually desert-like. You see the sand on the surface, but it was not always the same. And this, what we can see from this pollen record of the Taixijuan peat, you see between 6 and 2,000 years ago, we have sometimes the amount of pollen grains produced by trees up to 90%. But this changed very quickly between 3,500 and 3,000 years ago. And using the pollen data, we can reconstruct the change from the temperate deciduous forest to the forest steppe and to the steppe environments through the period between 6,000 and 2,000 years ago. This was corresponding to a decrease in the annual rainfall from 600 millimeter to the below the present level, about 300 millimeter per year. And well, we can say, who was the reason for this? What was the reason for this change in the vegetation? Human or climate? Well, comparing the record with the record of isotope data from the Chinese stalagmite cave show that the actually reconstructed change in vegetation and precipitation is parallel to the weakening of the summer monsoon in this area. So weakening of the summer monsoon caused the change in precipitation, change in the vegetation, and then this change, few hundred years later, caused a big change in the regional economy from the millet agriculture and fortified settlement to the field, to the abrupt change to more husbandry and the mobile pastoralism. So coming to another example, which is 1,500 kilometers to the south from Taixijuan site, you see here, this is a Taiwan island, and the site is completely different. You see the forested landscape, the green fields. Well, this area is controlled by the monsoon today. It's obtained 1,700 millimeter precipitation per year. When we are looking the change in the pollen profile through the last 10,500 years, we see a very similar picture in general. Quite a high content of tree pollen during the period between 10,000 and 3,000 years ago, and then the abrupt change towards the very few pollen of trees. And this, of course, if we are reconstructing the vegetation, is telling us that there was a big change from natural, warm, temperate, broadleaf forest in the area to the open woodland. If we are looking on the data of the monsoon, the Pacific summer monsoon changes, well, this is the same picture you have already seen. And well, the very low, very weak monsoon precipitation is slightly later, about 2,000 years ago. But earlier, we see a big dramatic increase in the number of sites, archaeological sites in the area, and then continuous growth of population in the Fujian province where this site is located. So we see again the same question, climate or man? In this case, it's a different answer. We see the big, quick change in the economy in the region from the very few hunter-gatherer living in the area through the several millennia or many millennia before 3,000 years ago, and then immigration of the agriculturalists, starting of intensive roading the forest and the so forest clearance and the rice agriculture after 3,000 years ago. So in this case, man is a primary factor for changes in the environments. We see the last slide, complex problem with no simple answers. What do we need for addressing it successfully? So first of all, you have seen that we need a joint effort of archaeologists and geoscientists. We need a suitable archives and reconstruction methods, and we need a robust dating or chronological control from both sides in order to discuss these changes consistently. Thank you very much.
Thank you. Now we've heard that not only climate change, but humans can change landscapes in history as well. We now move a little bit to the west, to the Sahara Desert, here in the plains. Paleobotanist Michèle Dinies is seeing as well influences not only of environmental change, but of cultural interactions as well. We all know the Sahara is the world's biggest desert, but how did it look 8,000 years ago? 6,000 years ago, sorry.
Okay, yeah, thank you very much. Now then, Pavel Tarasov just told very nice how pollen are very useful tool to reconstruct climate change and at the same time to reconstruct human land use. And now we want to show you an example of the desert of the Sahara. So this is a picture of the actual Sahara, but as you all know, the Sahara was green some 1,000 years ago. Here you see the Sahara as it is today in a simulation with the large desert here and the savanna and the grasslands. And here you see a simulation of the green Sahara. Here you see how the savanna woodlands spread to the north and the grasslands too. And what we are doing now in our project at the moment is we are doing a ground check regionally in the central Sahara. And we do this by analyzing a sediment core, similarly like Pavel Tarasov does it with his crew, but we do it out of the Lake Eure here in the central, situated here in the central Sahara. And here you see the nicely laminated sediment. So we are able to deal with one of the things Pavel just mentioned to build up a robust chronology. And we are doing pollen analysis as on these cores too. And here you see a pollen diagram. Don't worry, I won't go into any detail, just to show you how the data looks like and which we did use afterwards, the climate reconstruction and the land use reconstruction. So just one glance, here's the pollen diagram, and it starts about 10,000 years ago and it ends today. And here you see a few selected pollen types representing different vegetation formations, and they're a little bit color-coded. So you see in yellow here the desert vegetation, here the semi-desert vegetation in orange, the savanna more dry adapted, and here the real green savanna from the green Sahara. But as I said, we won't go into detail. And what we were looking now is on the aridification. So we don't look how it became green, but how it turned to the desert as it is today. And to make it more easily to understand, these three photos might give a sketchy impression what really happened in the Sahara. So we have the savanna and then the aridization until the desert today. And of course, you can imagine that these dramatical environmental changes necessitated adaptations or required adaptations for plants, animals, and peoples. Yes, and the most common thing and what we think always about is the migration. Yes, so people and plants and animals go in other places that are adequate for them. But of course, concentration on remaining favorable sites, such as oases, is another possible adaptations. And of course, humans can do other things, such like transforming social systems. This, of course, we can't trace in the pollen record, but we can trace the changing subsistence strategies. For example, the cultivation of different crop plants or fruit trees and things like this. And as I just mentioned, if we look on the cultivation in deserts, the places where it usually took place are oases. And oases can be quite different. As you can see here, there are nearly natural oases, and there are oases where cultivation is intensely done. For example, the date palm cultivation without irrigation in some oases or with irrigations. And here you can even see a very extreme thing. It's a completely artificial oasis where fossil groundwater is pumped up and then an oasis is created. But going back to the history of the aridification and the oasis as possible places where adaptations could take place, we may ask the questions, is there something like an oasis package that spread synchronously with aridization? That would mean, is there a pattern that when it becomes more arid, the same things happened in oasis? And here we want to show you only the results of two different oases we are investigating at the moment. The one is the Lake Ewa I just presented you in the central Sahara in the northern part of the Chad. And the other for comparison is the oasis of Taima in northwestern Saudi Arabia. And if we go back in time by our pole diagrams and put it in this picture here, you can see the following thing. If we go back 4,000 years before Christ, you see that at the oasis of Taima was already an oasis. There it was dry, it was surrounded by a desert shrub vegetation, and there grapes, wine were cultivated. They were imported from the north and were cultivated. If we look at the same time to our Lake Ewa, you see Lake Ewa wasn't an oasis at that time. Yes, it was a lake surrounded by a savanna. If we go further in time to about 1,000 years before Christ, you see that at the oasis of Taima here, there was cultivation of the grape vines, and there was a cultivation of a lot of other typical oasis trees like the date palm or the pomegranate. The same you can record in another oasis in the Sahara, the German oasis. Date palm, grapes, and pomegranates were cultivated together with other fruit trees. And now if we look at Ewa, you see it's an oasis now. The lake is surrounded by desert vegetation, but no fruit trees cultivation could be traced 1,000 before Christ. If we look at the time slice at 500 after Christ, you see that at the oasis of Taima and at the oasis of Germa, the fruit tree cultivation continued, a large spectrum. And at Ewa, we saw a little bit date palm cultivation, but mainly a propagation of a native palm, the dut palm. And it was only 1,000 after Christ, 1,000 years before present, that the date palm cultivation was very important, similarly to other oases, such as Taima. Thus, if we go back to the question, if we can see a general adaptation pattern to aridization in the Sahara-Arabian belt, we may see that the oases become much more important during this aridization, but there seems to be no standardized answer to these environmental constraints. In contrary, you see very strong regional differences and possible adaptations. Yeah.
Thank you. This was one hint that not only climate change, but the cultures dealing with climate change are very important as well. And this goes nicely over to the talk of archaeologist Detlef Gronenborn. He developed a model of the development of societies, trajectories which are driven by processes within these societies. So how does your model work?
I will talk about a very remote period, nevertheless, one of the most important periods in global history, with a focus on Europe, or rather on Central Europe, namely the period when people changed from a hunting and gathering lifestyle to a farming lifestyle, which for our region here happened at the end of the last glaciation, in the so-called Fertile Crescent, and from there on, people migrated outwards with this new technology. We will specifically look at the green blurb in the middle, namely at the region of Western Central Europe. A few words need to be addressed, however, to our theoretical model. It is sort of based on something that has been derived lastly from psychology and then made its way into the environmental sciences, namely the adaptive cycle model. It is shown in the right with this sort of H-shaped or eternal shaped confusing progression. For our purpose, we have simplified it a little bit and stretched it out and put it into a two-dimensional scheme with which archaeologists and or historians are more familiar with. One component of this H-shaped model, one component that sort of forces the progression within the model, is a factor which is called resilience, or sort of the span between resilience and vulnerability. We have sort of broken up this resilience concept and added it to what we called the complexity parameter. However, resilience is still there. One problem that most of the theoreticians and most of the archaeologists and historians have had with the model and with the adaptability of the model is, if we think in terms of resilience, which is very helpful, we need, however, nevertheless, get away from the intuitive metaphor that the term is. So we need to find in the archaeological or in the historical record, we need to find signals that can be quantifiable and that hopefully stretch over a long period of time, that sort of give us a help of coming to grips with this intuitive metaphor, adding, so to speak, a firm data to it. We have looked at the variety of archaeological signals. There are many out there. And we have come to the conclusion that pottery decoration is one of the best signal carriers for resilience, or rather for the factor that comes out of resilience, or that expresses resilience even better, for social cohesion. Because we think, I can explain the theoretical background later on, we think that resilience is sort of produced by fluctuations in social cohesion. Resilience can be produced by many other factors as well, but maybe one of the most effective and most dominant one are fluctuations in social cohesion. Those that deal with long-term history know that since the beginning of classical antiquity, classical antique historiography, social cohesion is being considered in theoretical models, and so we do still today. So we need to find something that expresses fluctuation, social cohesion in the archaeological record, and we think that pottery decoration is a good signal for that, because people indicate their social identity with pottery decorations, and changes in this, temporal changes in this pottery decorations indicate changes in the way people identify with themselves and on various scales with these societies. So basically what we look at changes in pottery decoration and interpret them in the way that they reflect changes in social cohesion. With these time series that we produce, we go and talk to the paleoclimatologists. For us, it is always, well, if you deal with paleoclimatology on a high resolution level, it is good to look at very local sources that reflect the local climate. And for us here in our area, we look mostly at the Sauerland Sauerland records from the Bunker Cave, which is has a high chronological resolution and gives us some indicator on precipitation and and more or less also temperature. So these two records we compare, and we look at the first farming societies that we have in our area, the so-called linear pottery culture. We know from 150 years of research, it's a simple farming society. We know it is lineage-based. People lived in dispersed settlements, and people had no marked hierarchy. So they're basically simple farmers with a very effective farming system. They have built hundreds and hundreds of settlements. So we have a very dense data system. With the method that I explained before, we are able to derive at scaled curves of what we interpret as changes in social cohesion. So you see the orange curve and the yellow curve. These are basically changes in the diversity of pottery styles, which we interpret as changes in social cohesion. And we compare these with population estimations, and we see that some of the social cohesion fluctuations correspond quite well with the population curve, but others at a higher level do not. They sort of take their own dynamic, and we also compare these population curves and the curves of social cohesion with the paleoclimatic curves, and we can see sort of that all curves generally follow the indications of the climate curve, but that there are certain deviations. For instance, the general curve up here only coarsely corresponds to the climate curves, but the curve at the lower level corresponds to some climate excursions, but not to others. And this can be repeated for the Middle Neolithic and actually for another cycle, which will be too difficult to talk about because it would extend the presentation too much. One thing that needs to be stressed from this curve and other curves is that not only when climate turns bad has an effect on these society, but also when climate turns good. So we see a diversification increase or a change in social cohesion towards more diversification when the weather presumably gets better, and also we see changes in population curves when the climate gets more drier. And then at the end, when it gets back to humid and wet and cold, we see all curves declining. So it's sort of a constant feedback between positive and negative effects that produce these curves. Lastly, I should say,
societies react to the climate, but they have their own dynamics as well.
Societies react to the climate, but they have their own internal dynamics as well. And one thing is that strikes us most is that when people become more and more, hence one would think they're doing much better, they begin warring for no reason. So we think that societies undergo an internal dynamic which ultimately leads to their own disintegration, because other colleagues that have applied the same method in regions where the climate is rather homogeneous find the same curve progression but no real general link to climate. So we think that the social cohesion curves is something that is a given, and climate operates as an incoming external factor, shortening or widening the extension of these curves.
Societies on the world generally do get better. So we have a lot of population, a lot of technology. So we are at the end of this internal cycle. Maybe we can try to bring the other participants back into the discussion, and I will want to mention that all of you, all of the people listening to the discussion can join in using the Zoom chat function or using Facebook, using Twitter, whatever. When we look at your different presentations, we see that this global phenomenon of climate change plays out very differently in different settings. So is there any possibility to link these data dots we have on the interaction between people and climate, regional climate in the past, into a bigger story? Mathematical models, for example, one way to try to integrate your stories into the broader picture?
Yeah, just to give you an example, when we have a lot of sites investigated, we have just individual, often contradicting results for certain periods and for the sites, and often with quite different conclusions. And to integrate all that, we have a lot of tools and very different types of models. So for example, we can regionalize these information, these point data or site data, using recent information about the topography, so the relief, the slope angle, about the recent soil conditions and land use, and see if there are any correlations between the recent situation and the different past situations. So by that, we can check if our conceptual models fit or if we have to develop them further on. So this is one possibility, more a geographical method to come from the point in the 3 spatial dimensions and then adding the time as a 4th dimension. The other possibility of modeling is in all available scales from a point to the whole Earth land surface, that we use mechanistic models. Just to give an example, how a raindrop passes the soil to the groundwater over a spring into the rivers, or when it's a heavy rainfall, directly over the surface to the rivers then, and all attached material, chemicals, so nutrients and so on. And also this recent modeling helps us to understand better the processes that occurred in the past. So we have a huge variety of models. Detlef has shown one great example, and I just added a few more of this huge box that we have there of modeling.
Do you use models as well in your research? Michèle, Dinies or Professor Tarasov?
Yes, I can tell also. I mean, if to think the ancient Greeks philosopher told that you cannot 2 times step in the same river. And this is also true for our research. So when we're asking what can we learn from the past? So we can learn the number of scenarios which are then allowing us, or modern scientists do in the complex models, to test these models in order to say, okay, this model is good for the prognosis of the future scenario or development of the climate change and the impact of the climate change on the ecosystem. We need to say which of these 100 models is better, or which is, well, very good and just can be trusted and so on. So in order to test the models, we are frequently asked by the modeling community to provide our on-site research results, reconstructions in the site A, B, C, and so on. And this data is very useful for testing the model and to make then necessary changes in the modeling procedure in order to get the better results. Yeah, you see, if we are successful with the model to simulate the past, we can also be more or less confident that it's simulate the future. So this is our contribution to the models.
Just one sentence, I think too, we are working, for example, with the modelers in Hamburg together, and as Pavel Tarasov said, they often come to us to validate their models, and I think it's great to model things, but there are big challenges too. For example, if vegetation modeling is done, usually they reduce the plants to trees, shrubs and grass, yeah, and so the world is much more complex, yeah. So I think modeling is great and it gives a lot of input and ideas in which we can think, but yes, most of the time it's a reduction, yes, at the same time, and I think that's a big challenge. We can try to interact more, and yes, we can profit more both times. And I don't know if it's the same for you, Pavel Tarasov, but sometimes, as you said, we sit there and count for years a pollen diagram, and the modelers, they just they press one button and model the world and explain the world. And yes, there are sometimes a little bit differences, and we are sometimes discussing very heavily, no, not in this direction.
But this is a common problem, yeah, to have a communication, general understanding between the different groups of scientists. For this meeting is very, very important and very good, because yeah, climate modelers are saying we need a data set. Archaeologists are saying, oh, you are talking about the region, but we are working on one site. We need this real local data. So there is a such problem of understanding, but only through the really collaborative research, we can deal with such problems and solve them very successfully.
So I wonder, when we talk about how people in ancient times reacted to climate change and cope with climate change, what is the right level to look at their environment? Is this the landscape, as Professor Bork discussed, or is it the very local profile of rain, or is it the biomass in the region, the available resources? So what is the level where climate really becomes a force in the life of people in past societies?
Yeah, well, with these two examples I just presented, it was very clear that there is a climate change which is the same in a large region. We have a reduction in the rain, but in one region, this reduction of the rain is bringing actually a big change in the vegetation toward the desert and the people, towards the dry steppe, and the people are changing their economy from the agriculture to pastoralism. And in the other region, the same decrease in the precipitation was actually favorable for societies dealing with rice farming to come to this area, because before it was simply too much rain. Even now, you know, in this Southeast China, we know this from the news, this terraneous rains and the floods are very, very big problem. But if we have even stronger monsoon, more rain, then it was actually very difficult to keep the fields and to live there. So that for many thousand years, the hunter-gatherers lived more successfully there with their economy than the agriculturalists. Even the ancient region of rice agriculture was just a few hundred kilometers away from this site. Yeah, see, this is.
So climate change is a very local phenomenon. So when you all look at your different data sets, there seems to be, on the one hand, there's climate change, different plants cropping up, or different possibilities showing up for people. And on the other hand, there are these cultural processes within societies that Professor Gronenborn described. Do you see these cultural reactions to climate change as well? I think, Michèle, Dinies, you said in your OASIS systems, there were quite different cultural reactions to the same kind of change in the availability of water.
Yes, so we can, I think for archaeologists, we don't see really the cultural change because we see only the changes in subsistence strategies. Yeah, so that's our indicator to approach these things. But yes, there we see huge differences and we see really regional answers, but they probably were connected to bigger cultural phenomena. So for example, the oases that were very early cultivated, they are intensely connected and part of trade routes. Yes, and for example, Lake Ewa, the oases who stayed really autonomous and were not cultivated before 1,000 years ago. So it's really in the center of the Sahara, and no big trade routes went through it in earlier, only in the last centuries it started to get integrated. So I think this we can see both. We can see regional answers like the native date palms that are used, and we can see probably changes that are linked to cultural processes from outside coming to the oasis. Yeah.
And a question to all of you: what do you think can our societies today learn from the reactions and interactions of past societies with climate change? So are there lessons from the past for today? Yeah, Professor Bork?
Just one example, if we just pick up the extreme events again, different sites are very different, vulnerable. So when we check how the people reacted in the past and which extreme climate events we have had, very often the situation is quite similar today. So which areas are very prone to catastrophes, let us say hilly less areas, much more than a sandstone hilly region or whatever. So we can take a lot of information from the past for the today, for example, landscape planning, how we should develop new settlement areas or industrial areas, and where it's better not to develop them. So this is just one example.
Professor Gronenborn?
One difficulty I have with looking at our current global situation from the past is that, and we've just learned it this year, that our climate change is unparalleled in any part of human history. It goes faster, it goes to more extremes, and it's parallel across the globe. You know, previous scenarios, you had things happening here, things happening there, and societies were able to address these individually. But now we're faced on a global scale with a situation which has more or less gotten out of hand. So I'm not quite sure whether we can, I agree, you know, when it comes to local desertifications, we can look in the past and see how people have dealt with desertifications. But on a global level, I'm not quite sure how we can benefit from the past, because the past has always has never been that interconnected as we are today. I think the challenge is much bigger than anything that any society in the entire history of humans has ever faced. That's a bit pessimistic, but
I would like also to say a few words about this. Well, we can learn a lot from the past, particularly from the past societies and past examples of the dealing with catastrophes from the local level management. You see, for example, we have a very interesting study some years ago dealing with one village with what partly destroyed by the mud flow. So it was a catastrophic rain, and the mud flow destroyed the half of the village, and it was speculated. So in some houses where people found the skeletons of the people, and the discussion, what was this? Maybe a Pompeii-like or something. But in fact, it was a mud flow. And interesting, this was happened 4,000 years ago. since that time, when we made a modeling of the landscape with the students from Potsdam and Berlin, we realized that people never built houses in this area, which was affected by this mud flow. So the village was there for 1,000 years, but it was just a few hundred meters away from the place where this mud flow destroyed the houses. So now, because people are, well, as Detlef told, that we are actually too multi-cultural and so on, and the people who are building the houses in the wrong place, they are very often not living there. They are only getting money from the people living in this place. Therefore, we have a lot of examples in the past years when such kind of, as also Professor Bork told, such unthoughtful building or unthoughtful development of the certain area without connection to the previous experience create a big troubles. So this we can learn, I think, also.
A short addition to that, what Detlef said, I agree totally that what is going on today with climate change, global change, is uncomparable in human history. Nevertheless, in the past, there were certain events which have had over-regional effects. Let's just take the late antique Little Ice Age. We're starting in October 536 AD. The sun wasn't shining for several years, and it is reported in contemporary documents. There it was not warm as it is today. There it was very cold and wet, and changing the game totally in most societies on Earth, maybe except the Chinese. So even from that, we can learn how a hemisphere may be affected in that case by climate change as a consequence of volcanic eruptions in 536 and in the following years.
There's a lot of population got down, I think. So the lesson might not be a nice one. We now have the first question from the audience, from Sabine Reinhold. She has a question for Professor Gronenborn. What would you suppose from your case study and other sources about the offsets of resilience? How long does a traditional agro-pastoral society can keep its way of existence and economy under environmental pressure until they have to quit the area, migrate, or break just down?
All right, thank you for your kind words. I was just replying in writing, but I can also talk, or rather read what I was just writing. The method that we need to apply in the early Neolithic societies in Central Europe does not allow us to go to time spans shorter than 20 to 25 years. So we also watch everything through a grade system of 25 years. So we cannot say whether they reacted in a time period shorter than 25 years. Within these 25 years, we see rather immediate reactions. But for those people back then, this was an entire generation. If we look at the ethnography worldwide, basically, of simple farming systems, we see that these people took decisions after 3 years. If an unfavorable situation persisted more than 3 years, most of the storage was used up and they had to take decisions and change the strategies. And we presume this was the same for the prehistoric European societies. You ask about agripastoral systems. That of course is a bit different because cattle can be managed in other ways than harvests. But I presume 3 to 5 years is the limit for these simple farming or agripastoral societies. Does that help?
Probably. We have to wait for the next writing. I would like to ask it's really important, the collaboration between natural scientists on the one hand and archaeologists on the other hand. But you're dealing with quite different sets of data, which are the data of pollen or tree rings. They are sometimes dated to the year. On the other hand, if you have to rely on cultural changes, if you have to rely on the markings on pottery, which change on different time scales. So how easy, how difficult is this for you talking together? Are there many misunderstandings, or is the field now so open that there are easy discussion between these different subdisciplines? Yeah.
Just to start, of course, first we have to define the key terms that we know what we mean when we talk about certain topics. But nevertheless, I think, namely for the archaeological excavations themselves, so for the normal archaeological work, it is very fruitful when you have a cooperation with very different natural scientists from botany, zoology, from geophysics, from physical geography, and from paleoclimatology, because when they take samples on site, so at the archaeological sites where villages or towns or cemeteries are investigated, you get really coherent data sets, and a lot of improvements were made there in the last decades. I think at least in Germany, in Europe, in Northern America, most excavations today are carried out together from archaeologists and the other disciplines. They are no longer, as we call it in Germany, the Hilfsdisziplinen, so the helping disciplines, just bringing in certain information from outside. No, today we are defining together the goals, we are defining together the methods that we are using, and we are analyzing the data together, and we are publishing together. So it's a lot of improvement that we have had in the past years on site. And of course, there's off-site investigation. Some examples we have given today in our short talks, where it's much more difficult to bring them together with the archaeological investigations. By the help of models, a lot is possible, as we have seen already. Thank you.
So maybe I can also add a few words to this topic. Yeah, well, everything depends on the wish to discuss things, to work together, of the understanding that together we can address the problem from different sides. But if we are talking about this, well, comparison, the scale, annual or decadal or centennial, this is, of course, also a bilateral process. For example, we work together with a dendrochronologist from German Archaeological Institute, Dr. Hosner, and by excavating together with Chinese colleagues one grave in a very remote area of Western China, they found a lot of wood which was used for constructing this grave. It was maybe a kind of noble tomb of a chief or king, local king, and just investigating this archaeological material, Uwe Hosner created the longest tree ring chronology from the region, going back to 2,600 years ago. And this, in turn, when he shared these results with me, with us, we were able to produce a curve of the annual rainfall for this area for the past 2,600 years. So this is how the communication, how the connection of the research, archaeology, and environmental science can bring a benefit to both of us, to both sides. This is.
There's another question by Barbara Zach. is it possible to parallel changes in pottery decoration with change in food crops or animal husbandry? So the connections within the cultures. Professor Gronenborn.
Hello, Barbara. It's nice to hear from you again. We've been to Africa together many years ago. It is when you have high resolution paleobotanical data. But of course, this is seldom the case, but for the LBK, we are beginning to see structures, but I don't want to go into detail yet because it's research in progress. But it only works in certain periods and times, and you need a lot of archaeological and paleobotanical data and the right preservation conditions.
Are there any archaeological pottery findings at the oasis you work with, Michèle, Dinies?
So at Timer, yes, and I think there Arnold Hausleiter in one of the next sessions can talk a lot about because I'm a botanist. But unfortunately, at the oasis, for example, in Onyanga, it's very hard to do excavation there because of political and infrastructural reasons. So there is nearly nothing, and there we have the big problem that we have a rather high resolution archive for climate reconstruction, landscape change, but the archaeological information is very from really over regional. Yeah, so you have, of course, the herders and the cattle cults and things like this. Yes, but that's a very rough chronology, and to put it really to, let's say, for example, we have the 8.2 event, 8,200 event in the Central Sahara. We can date up to, yes, hundreds of years or even 50 years. And then to put these large chronologies together, it's hard, yes. And so I think it's the challenging thing at the moment. People for looking at cultural changes in the Sahara, one fraction say, okay, the aridization was slowed down by the herders, and the other fraction relying on the same data, they say, oh no, the herders accelerated aridification, yes? So if you don't have concrete chronological controls and hard facts really for a region together, data can use for contrasting arguments. So that's at the moment, not only did the desert dry out suddenly or not, but the other thing is, did herders prolong the Green Sahara, or did it shorten down? Yes, so yeah.
Well, there's another question of the audience. This is from Sine. She wants to ask, do you think that, what do you think of the collaborative research with computer scientists? Do you think some common problems could be addressed? Have you already collaborated with computer scientists, and in which case studies? So, Professor Bork.
Computer scientists are integrated more and more in the large collaborative projects today in very different ways, namely for the handling and the management of the big data problems, of very heterogeneous data sets, of modeling. So they are today a part in the larger projects, at least.
Yeah.
About 10 years ago, we had publications with mathematical modelers or computer scientists that showed that climate actually played a minor role in the expansion of farming. To our great surprise, we wanted to find out something totally different, but this is what the computer simulation suggested. It's published, I think, in the Journal of Archaeological Science.
Yeah, well, I think another aspect of collaboration with a computer or IT specialist, it's, for example, to extract the data from certain sources. For example, we analyzed about 30 volumes of Chinese atlases of archaeological sites. They were only maps. So it would be just a years if we are digitalizing or trying to take side by side information from these maps, which even didn't have coordinates. But with a specialist writing the software, when we explained him what is the task of this project, he was well successful to create a software to get this information from the maps, and we could publish several good papers and also provide this data for the open access use for the community. So this is an important contribution. Another is in general, yeah, creating the software for certain purposes. Climate calibration, climate calculation is possible, of course, with Excel or with certain software packages, but it would be much more quicker and much more nicer when there is a software created specially for certain tasks. And this we are benefiting, of course, from such cooperation.
I have to go back to Professor Gronenborn. You mentioned that the expansion of agriculture was not driven by favorable climate. So what was the driver then? Just a short answer.
No, it had a small scale effect. Well, judging from what I've just said and what I only now know, not back then, I think it were internal social dynamics. And of course, one big factor is population. Population has been debated over and over again, but we know it were many more people than before, and these people needed to make a living somewhere. And that, yeah, that together drove, and maybe also there's a factor of curiosity.
Okay, this brings us to the next question by Ferran Antolin from Basel. He asks Dr. Dinies that he got the impression that the Saharan lakes and oases only started to be dwelled at after aridification starts. Is this correct? And why would this be the case?
I think perhaps I have to say there are not many oases investigated at the moment. So we have a very reduced picture, yes, but it seems that at the moment, yes, that at least cultivate crops like the date palm that are imported from outside and then cultivated somewhere. In the Nile Valley, it was very, very early, yes, and in satellite oases, in the Dakhla oasis, for example, or like this or Farfara, it started at about 4,000, yes, but the inner Saharan oasis, they seem to be very, very lately cultivated by crop plants, and it's even later in the western part of the Sahara. And the hypothesis at the moment really is because there wasn't that much cultural connections, and there was perhaps a larger variety, at least in the Western Sahara, perhaps plants native there, they could be used a little bit. The old idea of the Garden of Eden that was there, and that's why the people didn't start earlier. But as I said, it's very, very at the beginning. For example, the German oasis I showed before, it's really a Garamanten culture connected to the Roman afterwards. So that's a cultural thing, yes. But in the Central Sahara, they perhaps didn't have the contacts or didn't need things like this. Yeah. But it's really at the beginning, and it's the same for the Arabian Peninsula. Huh? We were very astonished that they started very early cultivation, because in other oases, the date palm comes there as only several, much later than we expected. Yeah. But it's really research in progress.
So I would invite the audience to ask further questions. We still have some minutes, so if you are interested in some aspects of the topics we discussed, now is the time to ask your questions. One point I wonder is, some of you work in locations where there are still people which live in similar conditions. So at the Oasis, for example, so are they interested in the work you do? Are they interested in this long view of their past?
I think I should start. So unfortunately, I was never in the Saharan oasis until now, but I was there in the Saudi Arabian oasis, and there they don't live anymore traditionally, we have to say. Yeah, it's really much more industrial. And I, of course, talked to the botanical part of the things, and they were interested, and they were surprised about a lot of things. Yes, for example, the late arrival of the date palm for the Saudi Arabian people, it was a little bit of shock, yes, because it's the national tree and it's very important. But I think they got more and more interested in, and it's not only exotic, yes, you know, and they looked how wood drilled and things like that. Yeah, so there is an interest there, but I think it could be much more cooperation. Yes, people always try to do it, and sometimes it's hard, but often it works. Yeah.
Yeah.
Just another example, we are carrying out some research on Rapa Nui, which formerly was called Easter Island, a part of Chile and the Eastern Pacific Ocean. And there the people are very, very interested in archaeological and paleoclimatological, paleoecological research, because they have a long tradition and long oral and detailed oral tradition. While when we work on Palau, which is in the western part of the Pacific Ocean, today an independent state, due to a very long colonial period, German, Japanese, US dominated colonial period, there's really a break and quite few knowledge about the past. And our investigations are now going on, but showing that we can improve the interest of the people on where they are living on, to understand really the landscape where they are living in. And that is quite fruitful when you have long-term cooperations, that with the years, the interest, the local interest is often increasing very much in certain regions.
Yeah.
I'm apart from working in Africa, I'm also working, as I said, in Central Europe, villages and towns not so far away from here. And I should say I have found the most interest in people within our local societies. You know, people identify with the archaeology, even if it goes back several thousand years ago. And I find a great interest on all levels of societies, from the farmers to the educated people, but not necessarily to all parts of society, and up to the politicians, even the state politicians, if they find the time for it. I think archaeology is well received, as it is in Africa, of course, but also here we should not underestimate our own people's interest in their own past, as it is.
Yeah.
Yeah. I also maybe say a few words. All experience of working in very remote areas in Russia or in China or in Japan, people are always interested in the local people are very helpful, and because they are interested in their past, they are always curious, asking, what did you find? What is all about? But they are also more and more interested in the help of scientists for environmental protection, for example. Yeah, when we are saying, okay, we are geoscientists, we are working with the environments. Oh, well, maybe you can tell this, or maybe you can write this or say it loudly. We need here to do something, for example, to protect the Lake Baikal or to protect the forest and so on. You see, this is a very, very important part, that the local people are very interested and very supportive.
Yeah, so thank you to all the speakers on the panel. I think we've reached a good point to wrap this discussion up. We've learned a lot about different ways to really gather data from the past to learn about how people, how the environment of people, the landscape people have to deal with changed and how fast it changed. But that it's not only a factor of climate which drives cultures, but it can be the other way around, that cultures drive not the climate, but the development of the local landscapes. We've seen in the example of Pavel Tarasov. So it's an interaction, and climate seems not to be destiny, but something which can be dealt with in a way, at least it could be dealt with in the past. So this was our session today, but the ground check discussions will go on next week. We start discussion 2. The subject will be impact of climate change on early cultures, case studies, and you can expect more details from East Asia, from Anatolia, from several regions, from Africa. We will meet next week at the same time, 6 o'clock on the 30th of September, and at the same place, in the virtual place, the internet. Unfortunately, we can't meet face to face, but I want to thank the audience for the questions and the speakers for the insightful presentations, and I'm looking very much forward to the next discussion. Thank you.